Hey, this is Jordan. This video I'm going to go over the basics of coding in VHDL. So, let's jump right in. First off, this is going to be based off of creating state flow diagrams and transferring those state flow diagrams into VHDL, but we're actually going to be writing the VHDL ourselves. Second thing is, I am much more familiar with C++ and sequential programming, and so I'm going to be trying to relate these things with that background. I hope you have a similar background. If so, it'll work out great. If not, I'm sorry. So, this is a basic Blinky flash and a light on an FPGA program. Well, this is our diagram. So we'll just have two states, an off state and an on state, and then in the off state we turn off the light, in the on state we turn on the light. And then we just have a delay between the two states, and it just goes round and round and round. So, when it comes to the flow chart, it's pretty easy, and actually the VHDL code is also pretty easy. So right here I have a wonderful little program that I wrote personally, and I'm still very new to this, so forgive me if I make errors and people know better than this. But I found this wonderful website that outlined very well more complex charts and used VHDL to program them. This is what the website looks like. It had a lot more complex of a chart, but it breaks this down in a very similar concept. And then it gives you all of their code, and it comments it pretty well. But this is the same thing, just a little more simplistic. First off, in Libero, if you ever decide you want to make a VHDL source, it should already copy several things in here, like library, and the IEEE library is very common, and from what I can tell, it's very useful, and so as far as I can tell, it's great to use always. Libero, which is what this is in, has colors for specific things, and yeah, we'll just run over the basics. First off, a double dash is what you use for commenting in this language, so a double dash comment, yay. Also, this is a stylistic preference, but all of the keywords used I like to put in all caps. This differentiates what is a text-based command versus a variable or something else that we're defining, a name versus an operator. Anyways, so when you first open up File, New, HDL, Stuff, it will already have a lot of this in here for you, which is nice. It has a comment section, and then it defines a library and its use, and then it has an entity section, and then a port definition, and then the end of that port, and then an architecture definition, and then finally a begin and an end. So I'm assuming you're working in Libero that will give you these initial things to start. Like I said, this is the wonderful website. Pause here for just a second if you want to copy it down. So from what you're just given, the library is great, and I left it verbatim except for I changed things to be all caps just to help me figure out what was what. This is the clock divider. I want the Blinky. So, entity Blinky, and if you've been watching other videos that I've created, this entity is great because when you go to a smart design, this is the entity. This is the little black box that contains the stuff we're writing. This is Blinky 0 because it's one of many Blinkies. So, this is saying, hey, this process, this state diagram is going to be called Blinky. So entity Blinky is, and then you define port and then at the very end you do close parentheses, a semicolon, and then you say end Blinky. So in a lot of ways, comparing this to C++ or C, this is kind of like where you define your variables. Now, here, standard logic is the variable type, clock is the name, and then here you also specify whether it's an input or an output. Standard logic is something very convenient that comes in this IEEE library, and as far as I can tell, it works great. Use it. It's wonderful. So, first for this Blinky program that again is going to approximate just this off-on type of relationship, I just want a clock, because you need a clock in everything. An enable is convenient. A reset is also convenient, and then LED is our output variable, and those are our variables we're going to use. And so port kind of defines the I/O of the port, not necessarily everything you use inside of this, but it defines your I/O. Next is your architecture. This is where you do the rest of your definitions and make sure everything's good and happy, and all of your other variables that aren't necessarily your input and outputs. These I'm calling them variables, but they can be, registers or signals or different things like that. But again, C++ background, variables. So architecture, and I'm just calling it architecture Blinky, of Blinky. So it's saying this port that we've defined, we're also going to define more internal variables, which we're going to say is the architecture of it. And so here I'm defining two states, because that's what we have in this wonderful diagram. We've got a light off and a light on. So state type is LED off, LED on. So I'm saying I'm making a state diagram, and there's going to be two states, and I've listed them. And then here is a signal that uses these states. So it's almost like I've declared my own type of variable, and then these state and state, this variable state is of type state type, which can have either LED off or LED on, kind of like an enum type of a thing. So then we jump into the begin process, and then pass in whatever we need. In this case, it's clock and reset. The LED you don't need to pass in, and the enable we also don't pass in, apparently. Anyways. Oh, we don't pass that in, but we use it. Anyways, like I said, look at the website. So all we do here is we more or less set up a couple of if statements and then a case statement, and then we just define the relation between, we define all of the states and their relationship between each other, and then at the very end we say, if you're in this state, do this, if you're in this state, do this. So we set up the structure before we set up what happens inside the structure. So here we have, if reset is equal to 1, then go to the state LED off. And this is an assignment operator. In C++, you would just generally use an equal sign, but because we have a lot more different definitions and things are different, this is the assignment for this specific subset. So if reset is being pressed, then we don't want our light to blink. Else if, and notice this is not a full else, it's ELSIF, else if, rising edge of clock, then. So this is just saying if we're not being reset, rising clock gives us, as long as we're getting a clock signal, do what you should do. So then we just make a very simplistic case statement. case state is, so for our state variable, when case is LED off, or when others, so this would be LED on, but we need a default case, so in this case we put others. But getting ahead of myself. So for our state variable, when our state is LED off, then we do the following. If we're enabled, then we change to state on, LED on, and you always put an end if at the end of this if. So these are kind of like brackets. The if, open bracket, open curly bracket, whatever, and then the end of that is right here. So if we're in the off state and we're enabled, and we've already checked the reset, then go to the on state. And then when others is our default case. If we had multiple cases, we'd specifically list them, but you always want a default case, good programming and all that jazz. If, again, we're enabled, and this, then change the state to off, because we know if we're not in off, then we're in on, because we've only defined the two states. So if we're on, change it to off. And the if, which ends that, and case, which ends that, and if, which ends that, and process, which ends that. So what we've done so far in this, all we've done is we've taken and set up this structure of this state, and the transition conditions between the two states. We haven't yet defined the internal variables, turn the light off, turn the light on. But the nice part is, because we've defined a variable that tells us what state we're in, at the very end we can just say, and we've got an LED variable, and assign our LED variable to be 1, to be on, when state is LED on, else turn it off. And then we end that architecture, which comes all the way back up to this architecture. And that's all there really is to it. With this, coming back out here, if you watched previous videos, this little box should look exactly like our HDL code that we generated from HDL Coder. But the great thing is, we wrote it. This entire project is still a work in progress, but it's actually easier to write state flow diagrams in VHDL than I initially thought. So I hope this helps. Also, here's a clock divider that I found from this website right here, and I took it verbatim, and it seems to work great. So use this one or use another one. And I was able to successfully load on and blink an LED. Hope you can do the same, and I hope this gave somewhat of an introduction to VHDL. Thanks for watching.